Interior Alaska is a frozen, isolated expanse that guards its history tightly. Deep within the University of Alaska's archives sit thousands of these historical fragments. Recently, researchers launched the Adopt a Mammoth project, an ambitious effort to radiocarbon date 1,500 forgotten mammoth fossils stored in their collections. Two specific specimens caught their attention, cataloged as UAMN 3760 and 3724. These heavy, disc-like bone plates were pulled from the dirt in the 1950s by gold miners near Dome Creek, 400 kilometers inland. By every physical measure, their shape and structure matched the vertebral plates of a woolly mammoth. For 70 years, they sat in a drawer, accepted as ordinary Ice Age history. This timeline maps the accepted extinction window, indicating woolly mammoths vanished roughly 13,000 years ago. But radiocarbon results for the Dome Creek bones returned impossible dates of just 1,900 and 2,700 years ago. To put that chronology in perspective, this would place living, breathing woolly mammoths in the Alaskan interior during the height of the Roman Empire. This chronological gap forces a choice. Either our understanding of mammoth extinction needs a 10,000-year correction, or there is a diagnostic error with these specific bones. To find out which was true, researchers turned to stable isotope analysis. By extracting carbon and nitrogen from the bone collagen, they read a chemical record of what an animal ate during its final years. This scatterplot maps out isotopic signatures of different diets. Because mammoths were terrestrial grazers, scientists expected their data to fall squarely in the lower left quadrant. Instead, the collagen yielded a highly elevated signature, landing far outside the terrestrial zone. In biology, carbon and nitrogen levels this high are found in marine consumers, animals that lived and fed in the ocean. The situation was increasingly inconsistent. The data indicated a grass-eating mammoth found 400 kilometers inland that somehow lived exclusively on ocean resources. With the physical evidence making zero ecological sense, the team went deeper. They extracted ancient mitochondrial DNA from degraded bones to force a definitive identification. The genetic sequences returned a perfect match, but not for a mammoth. They mapped to the genera Eubalana and Balanoptera. The bones actually belonged to a North Pacific right whale and a common minke whale. Identifying the specimens as ocean-dwelling whales immediately explained the radiocarbon dating errors through the marine reservoir effect. Deep ocean water holds on to inorganic carbon for centuries before it circulates. Marine life absorbs this older carbon, which skews raw radiocarbon tests and makes their remains appear artificially ancient. Once researchers corrected for the ocean water, the true dates settled at roughly 1,100 and 1,800 years ago. The timeline was fixed, but the geographic paradox remained. How did the skeletons of two massive whales end up very deep in the dirt of the Alaskan interior? The team began eliminating transport theories. Natural riverine incursion was out immediately. Massive open ocean filter feeders physically cannot navigate the shallow channels of interior Alaskan rivers. Zoogenic transport was equally unlikely. The energy required for predators to drag multi-ton vertebral plates across 400 kilometers of rugged subarctic terrain has no ecological precedent. That left the human trade theory. Coastal indigenous groups frequently used whale bones for tools and architecture. However, a close physical inspection of the Dome Creek specimens revealed zero tool marks, grinding, or evidence of cutting. If nature didn't carry them, and ancient humans didn't trade them, the displacement had to be a modern phenomenon. The answer rested with Otto Geist, the prolific naturalist who originally discovered the bones in the 1950s. Geist was managing a massive volume of fieldwork across the state. Historical records showed that during the same season Geist was pulling bones from Dome Creek, he was also excavating a separate cache of whale bones from a site on the Alaskan coast. With thousands of specimens being shipped back to the university simultaneously, the coastal whale bones were commingled with the inland mammoth collection during cataloging. A simple administrative error placed the whales in the wrong drawer for 7 decades. Resolving the mystery of the Dome Creek bones didn't move a mammoth extinction date, but it did audit a 70-year-old error. It shows that paleontological progress often involves using new tools to look at the fossils we have already found. catching the archival mistakes that have been hiding in plain sight.